Alright guys, hope everyone's doing well. I'm going to give you a little bit of a remediation video here. Probably not the most entertaining one in the world, but after being in the woods and trying to do it that way, this is a nice hand video. But anyway, after being in the woods and having ticks on me and seeing a snake and running and screaming and everything, it was quite horrible. But anyway, so far we have gone from grams to moles. And we've also gone from moles to grams. Alright, let me just make sure, there we go. Next we've went from representative particles to moles, and we went from moles to representative particles. Now, I'm going to go through a few problems with these, and then I'm going to come back to this sheet. So to start off, say we are given 11.7 grams of diatomic hydrogen or hydrogen gas, and we want to go to moles of diatomic hydrogen. So as always, we take what we're given, 11.7 grams of hydrogen, and we put that over 1. After that, we want to get to our moles. So we're going to write that on top because that's what we overall want to get to, and then grams go on the bottom. Grams go on the bottom because overall we want grams to cancel out, but we're not going to cancel them just yet. Now if this was just hydrogen, we would just have to look at the periodic table and find that the mass of hydrogen is 1.01 and we would be done. However, this is diatomic hydrogen as represented by the 2 there. So as we did on that yellow paper to find the molar mass, we have 2 atoms of hydrogen. We're going to multiply that by our atomic mass of hydrogen, and we get 2.02 grams per mole. Now we're going to take that, bring it up here, and overall we are taking 11.7 and dividing that by 2.02, and our final answer is 5.79 moles of diatomic hydrogen. Alright, so that's how we do a problem where we are going from grams to moles. Alright, so if we go back to our original sheet, we did one of those. Instead of doing one from moles to grams, because all you would do is switch these two, we would have moles on the bottom and grams on the top. I'm going to do one where we are doing representative particles next. So if I have 8.9 times 10 to the 24th formula units of potassium hydroxide, and we want to get to moles of potassium hydroxide. So again, take what you're given, and we are going to put that over 1. Okay. So overall, we want to get to moles. So that's going to be on our top. And then on the bottom, we are going to write formula units. So on the top, we have 1 mole. And how many formula units is that? We're going to use Avogadro's number for it, which is 6.02 times 10 to the 23rd. Now, this can be for formula units, this can be for ions, this can be for atoms, or even molecules. But overall, we don't have to worry about our atomic mass and our molar mass for these ones, because there's always going to be 6.02 times 10 to the 23rd in 1 mole. So lastly, we just got to enter this into our calculator. So let me show you guys how to enter this in. Okay, so we are going to do 8.9, and if you remember, we hit our second button and above the 7 we have that little comma thing. We're going to hit that. So we have an E. What that E represents is times 10. And e to the 24th, and we are going to divide that by 6.02, second, that comma again, to the 23rd. And overall we get 14.78. So it is 14, sorry, let me refocus there, 0.78 moles of KOH. All right, so we did that where we went from representative particles to moles. If we were going from moles to representative particles, we would actually do the exact same thing, but instead of beginning with formula units, we would begin with moles, and that would mean these two numbers would be switched. So we would have moles on the bottom, formula units on the top. All right. Now, there's going to be some problems, and this is where, things kind of get really tricky, where we are going to go from grams all the way to representative particles. However, if we look up here at these 4 basic conversions, we don't have one that goes directly from grams to representative particles. We have moles to representative particles, and we have grams to mole, but nothing where we go straight through. So it's almost like we have a brother and we have a sister fighting. We need someone in between, someone to get in between this fight, and guess what? That someone is moles. Okay? So in this one, these are going to be 2-step problems. If you notice, all these have one arrow, which if we look over here, we have one arrow going straight from formula units to moles, so it required 1 conversion factor. When we have 2 arrows, one here and one here, it's actually going to require 2 conversion factors, one going from grams to moles, and another one from going from moles to representative particles. All right, so let's try one like that. I'll make it somewhat easy. Let's say we have 112 grams of NaCl. And we want to go to formula units of NaCl. All right. As usual, we are going to write what we are given and put that over 1. However, for this, we have to first, since we're given grams, we have to first go to moles. So let's do that how we did in the past. We have NaCl. We have 1 Na, and our mass of sodium is 22.99. We multiply 1 times that, we get 22.99. Chlorine, we have one of those as well. Our mass is 35.45. So when we multiply that together, we get 35.45. All right. Last step, we have to add these 2 numbers together, and we get 58.44 grams per mole. So let's come back up top. If I have grams on top, I need grams to cancel out, so we're going to write grams on the bottom. And then on top, we are going to have moles. So that's our first step, and this is where we are going to plug our molar mass in. So we're going to put 58.44 and 1 mole on top. All right. This will allow our grams to cancel. All right. So we are now at moles. Okay. We got there. So grams are completely gone and we are at moles. Now we have to do one more step. we have to go to representative particles, which in this example is formula units. So let's draw another line here. Since it is a two-step problem, we're going to have moles on the bottom in order to get moles to cancel out, and formula units is going to be on the top. This is where it doesn't matter about our mass of NaCl, our molar mass. In any compound, any molecule, any atom, any ion, we're always going to have that same number of 6.02, Avogadro's number, times 10 to the 23rd in 1 mole, no matter what. All right, so let's go back to our calculator here. And we are going to do first 112 times 6.02, second, that comma above the 7, to the 23rd, and we get that, and then we have to divide that by our molar mass, since it was on the bottom, of 58.44. And then this is going to tell us our total number of formula units, which happens to be 1.15 times 10 to the 24th. So coming back down here, we have 1.15 times 10 to the 24th formula units of NaCl. So this is like the one we did in class 2 days ago, where I actually took the salt, we weighed it on a triple beam balance, and then we actually converted it to how many compounds of sodium chloride was in that sample. All right, so this is how you do a two-step problem.